Hello and welcome to Get Smarter and Make Stuff. I'm Craig. Welcome back to the shop. We are here today talking again about the electronic lead screw project. If you haven't already watched my initial update on the project, you might want to check out the link. I guess that's right here, I suppose. No, here. Always get that wrong. Anyway, it'll be up there in the top, and you can click on that. It might give you a little bit better understanding of what we're doing here. Today I'm going to follow on from last time, talk about the problems that I ran into and the solutions that I came across, and hopefully we'll get this thing up and running today, actually attached to the lathe, and make some cuts. Oh my God. There's actually a frog right outside my window, trapped in the window well, that I need to go rescue, so I'll be right back. Alright, well that was an unanticipated diversion. Oh, I can see the toad right now in my field of view. He is climbing his way up the board. But unfortunately he seems to be slipping back down. I might need to go give him some more help. This is too good. I gotta catch this on video. He's slipping, poor little guy. I gotta do something to help him out. That's no good like that. Alright, well I just wound up picking the board up with him on it and dumping it out. And he's safe and sound now. I'll put the window well cover back on here so he doesn't jump back in. Alright, well there was a frog caught in the window well out there. I had to go and put a board in to help him climb up, but he was climbing up it, and I could see it's right behind the camera. And he was slipping down. There was no way he was going to make it out, so I had to go out and free him. I don't know if I'll edit that in or not, so we'll see if that winds up in there. Pretty amusing though. But now we're back here, and we can turn our attention to the electronic lead screw. I've got it laid out here on the bench with all the parts hooked up. You can see down in here we've got the stuff I was showing before, power supply, motor controller. So the issue I was having last time was that the display would not come on when you'd power it up. Wasn't sure what that was, thought it might be the controller board. So of course I said, well, it's either the display board or the controller, or the display board or the controller. So I ordered another controller, and because I had tried the experiment of running a very simple program on the board that would simply blink an LED on and off, and it wouldn't run. And so I figured, okay, it's the board. Ordered a new board, plugged the board in, and run the same program. Nothing. It's the simplest possible program. Just turns an LED on and off. Well, sure enough, I had gotten myself confused and was not running the program correctly, and when I ran the program corrected on the board, both the new and the old board work. This is not the first time I've done this, by the way. There was a prior point in the project where I had narrowed the problem down to either my wiring or the interface board, the control board that sits behind this display, and I convinced myself it wasn't the wiring and ordered a whole new control kit from James. Fortunately, he sells them at a very reasonable price. And when I hooked it up, it still didn't work. Sure enough, it was my wiring. I had failed to properly debug the problem. Okay, so it wasn't the controller board, so it must be the display. And sure enough, if you notice here, I've got this labeled bad. This is the old board, the one that I had. Somehow I managed to fry this one. I don't know what. Maybe I didn't do proper ESD, electrostatic discharge protection. Maybe I wired something wrong. Who knows? I'm not sure. Anyway, it's definitely bad. And it's actually good that I had ordered that spare kit from James, because it allowed me to take the spare LED board out of the kit and put it in. And now when I fired it up, the board would display correctly. So let's go ahead and actually just turn on the power here. I can show you. You can see that guy lights up. Displays the little ELS version 14, and we're good to go. We can get our readout for everything. But I'm going to come back to that in a second. I'm going to turn this off for the moment. Okay, so next thing is, that's all working. I would pick up the rotary encoder, spin that. The RPM indicator would light up correctly. So that seemed to be working good. So I plugged it into the motor, and nothing. Okay, so now what is it? Well, when I looked at the power supply, the power, the voltage, the output voltage display on the unit, which is, it's tucked down in there, you can't see it right now, dropped from the 50 volts, 48 volts really, that it should have been putting out, down to like 2 volts. Okay, so it's got to be either the power supply or the motor controller. I figured I must have, maybe shorted something out, burnt out the motor controller, so I ordered a new motor controller. Same exact unit, and, just pulled the connectors out of the old one here, put them into the new one, fired it up, nothing. I had guessed wrong again. Must be the power supply, right? So at this point, I had ordered one extra of everything, every major component in this project, except the rotary encoder. I guess I haven't broken that yet. But, 2 boards, 2 interface kits. I had a motor previously that wasn't working. I had to return. Now I had ordered 2 motor controllers, and now I needed to order a new power supply, or so I thought. So I did, and got the new power supply. Here it is right here. Plugged it in, exact same thing. Low voltage reading. Put the voltmeter on it. As long as it wasn't connected to the motor controller, then it would, read 48 volts. As soon as you connect it up, like a couple microvolts. But nothing was smoking. Nothing seemed wrong other than it just wasn't powering it. So, kind of at a loss at that point. Until I said, always check your assumptions. And sure enough, I had swapped the positive and negative inputs into the motor controller. Pretty lucky it didn't burn out both motor controllers, actually. And it did have the behavior it did, which is just to read low voltage, and I didn't set anything on fire. But as soon as I switched that, as we will see in a moment here, turn the power on, and get the motor turned around here so you can see it a little bit better. This thing comes up, and it might be a little bit hard to see, but if you watch the shaft there, when I turn this, it rotates. You can certainly hear it. Actually, give me 1 second. I'll put a piece of tape on that so we can see it better. All right, let's try that now. So if I turn the sensor, you can see that quite clearly. That thing turns, making a hideous sound, but that's just because it's not fixed down at all. So, success, right? Well, not so fast. I had hooked this up to the lead screw on the lathe, and we'll go look at that in a minute. But I discovered, even just turning it by hand, that there's still some stuff to get right. So let me grab the part that connects those two. Here it is. Okay. So let's actually go over to the lathe. I think it'll be a lot easier to see what's going on over there. All right, we're over here at the lathe. It's really difficult to get a camera in position, so hopefully you can see everything okay. The shop's just so full, it's so tiny, but hopefully you can see. All right, so I had tried to get the motor working at the headstock end of the lathe, but there's just no room down there. So I hit on the idea of driving it via this hex cap on the lead screw. I had made a little 3D printed mount for the motor, that I was going to sit up on a block of wood, since that's easy for me to get to exactly the right thickness. And then I would have an attachment between the shaft of the motor and a part that I fabricated to hold on to this hex nut at the end here. And so here's the part I fabricated. It's pretty simple. It's just a piece of aluminum I turned down on one end to be the diameter of this coupling, this motor coupling that I bought. It's just a El Cheapo motor coupling off of Amazon. It's got I want to say 10 millimeters at one end and 12 at the other end, something like that. So I turned it down so that this end would fit over is this end? This end. The big end would fit over the piece I turned on this coupling, and then on the other side we have it's sized to the motor shaft, so that would go onto the motor shaft and grip it. And there's some screws in this end to tension it down on that. And same on this end. I did machine a little flat. I don't know if you can see that on the end of this piece that I made to allow for a set screw. This piece does not have any set screws in either end. We'll talk about that in a minute. And then at the other end, I just machined this, bored a hole in this wide enough to fit over the hex nut, and then used a hex collet block. So a hex collet block and the mill to allow me to create 6 equally spaced set screw openings, tapped those out, and then I can slide that on, and I can tighten the little tight there right now. Let me just loosen those a bit so I can slide it on and show you. So the adapter block goes on there, tighten the set screws down, the this thing. I forget what it's called. It's a little bit flexible. That's actually why I want to buy it. It gives a little bit flex, so I don't have to get like perfect alignment between the motor shaft and the lead screw. I was kind of a little bit worried that if it was off a bit, that it would put a lot of stress on the lead screw. So then that goes there, and then let's pull the tape off here, and then the motor goes into this end. Tighten everything down, and when I ran it, what happened was a couple things. First of all, I found that the motor shaft was slipping in this collar. So I'm not sure if it's possible to really tighten this piece down enough just with these screws to grip the shaft. You notice there's no flat in there, even though the motor shaft does have a flat on it. There it is, a little flat on it for accepting a set screw. And so it was spinning inside there and not turning the lead screw. But sometimes it would, and one of the things I found is that when it did, if it would turn backwards, it would unscrew this hex cap from the shaft. And of course that's no good. Like, I don't want it to be pulling this thing off. So those are a couple problems I got to solve there. I think I know how I want to do it. I think what I'm going to do is take this little adapter, and I'm going to drill and tap a hole for a set screw in each end so that I can use that to grip the flat that I've machined on this thing in here. So I'll tap a hole like right about there. And then I should be able to grab this, and that should keep these two from slipping. And then I'll do the same thing on the other end so that it can go onto the motor shaft and keep that from slipping. And then as far as how to keep this guy from coming off of the lead screw, so down in the end here, I'm not sure if you can see it, but there is a capture screw at the end of this shaft, and I did tighten that down. I think it's meant to set the offset between the hex cap and the whatever bushing or bearing that is right there, so that it doesn't, bind. So I tightened that way down, and now it's a lot harder. Before I could back it off with just hand pressure, but I'm still not really thrilled with the idea of just relying on the pressure of that end screw keeping the hex cap from backing off. So I think what I might do is go ahead and drill a hole in this hex cap, and then use that as a guide to drill into the threaded end of the lead screw, which is not great. Like, I don't really love the idea of drilling into threads, but I think if I use this end cap as a guide, I can keep the drill fairly straight, minimize the damage. And then what that should allow me to do is run a set screw in far enough that it would really lock this hex end cap to the lead screw and keep it from rotating. I don't need even to drill all the way through. I thought about drilling all the way through and pinning it, but I think if I just make just even an indentation in there far enough for the set screw to run in and kind of get captured in that hole, then that should be enough to lock the two together. I also consider using Loctite. Loctite is basically a CA glue, like super glue, but meant for metal. At least the Loctite 603. This stuff right here. People speak very highly of it. I would be able to reverse it with heat, but I still think that the idea of coupling these systems mechanically using glue is, not the best idea. So I really think I'm going to do some kind of a hole in this thing and try to pin it together with a set screw. So that's the plan. That is going to require some milling. So let's go over to the mill and do the work we need to do. All right, we're over here at the mill. I've gone ahead and put that little collar into V-block. I don't have a collet that's big enough to hold it, so that'll have to do. I also can't find my center finder right now, but we're not really trying to be super precise. This is not a situation where, a thousandth of an inch matters. So just go ahead and chucked I think it's a 3/8 inch steel pin, precision ground pin into the drill press jaws, and I'm just going to use that to just touch the edges, and that should give me a pretty good idea for center, and I'll use the DRO to get me right there. So let's go ahead and get this guy figured out. Bring that in, bring this down, and below halfway, lock it down, and then looks like I need to wind it in X just a little bit more to make sure we're getting the high point of the pin, and then I'll just bring it over until I feel it just touch. Okay, so I'm going to 0 my Y, and then back this guy out, loosen these up. Okay, bring this over, and crank that in and Y until we hit right there. And I've just realized that I don't have this positioned exactly how I want it. I need to turn it a little bit so that I'm not too close to these slits, but that's okay. I can do that. This should be pretty repeatable, especially since I'm not super concerned with its position in the X direction. But let's go ahead and, okay, make a note of Y. 30, where's my calculator? Here we go. 36.52. Oh, we're in millimeters right now, but that's fine. So 36.52 divided by 2 is 18.26. So let's bring this guy up a bit, and let's move it in Y to 18.26. There's 18.22. I mean, it doesn't really matter that much, but 18.25, close enough. And let's just sort of visually confirm that that looks centered, and it does. So let's go ahead and loosen this guy up. And let's see, where do I want to put that? I think it's reasonable to have it close to, that slit close to horizontal. And actually, this dimension should be accurate for both ends, since it's the same overall diameter at both ends, so I can put it back into the vise a little bit more rather than have it stick out, and that should be pretty repeatable. So let's pull this out, and then the next question is, what size hole do I want to make? So let me grab some set screws. All right, here we go. I got some set screws here. Let's have a look and see what kind of looks good. All right, so I think that size, which, if you look on the lid, is M3. Looks like it's going to be about right. So, got to look up tapping size for M3. All right, so for M3, the drill size is 2.5 millimeters. I just happen to have a 2.5 millimeter bit. Figure I picked up this set on Amazon. It's been decent. I did break one, but that was entirely my fault. They seem pretty adequate. And it's pretty easy to replace a single one. All right, 2.5 millimeters. Okay, let's get this. Oh, the other thing I should note is I took off my ring and I took off my watch, and I'm wearing my safety glasses. Important to remember to do this stuff. I do not always remember, but I am going to try to remember when doing these videos. All right. I should point out, I'm pretty much a beginner when it comes to machining, so if you see something that I'm doing wrong, do feel free to leave a comment down below, because, you know, I mean, I've said this before, but like, the name of the website is Get Smarter and Make Stuff, and you are going to be a great source for me for getting smarter. All right, now unfortunately what I'm finding is that the drill chuck will not grip a 2.5 millimeter bit, so going to have to maybe do this over on the drill press, where I won't be able to be as precise, but like we said, it's not really a precision job, so we'll just go from there. Okay, so I realized that while I don't have the ability to grip a 2.5 millimeter bit in here, I can grip a center drill, and so I can get my holes started, and that'll actually, I think, help keep them on center when I go over to the drill press, where I don't have a precision way to align it. So let's go ahead and fire this up. Just take a look and see how we like to look at that, and back that up just a little bit. Kind of keep it in the middle. Okay. All right, that should work. And then I think we can just do the other end in the same place. Same spot vertically. Let's see how that looks. Yeah, it looks like it's about in the center of that section, so let's go ahead and didn't quite get it centered, but that's still fine. Like I said, not a big deal. All right, great. With that done, we can take it over to the drill press and put those holes in it, and then I'll just tap those off camera. All right, those got those drilled out on the drill press pretty easy. Looks like they came out pretty good. Oops. Just gonna chuck this back up in here because I think I might try to use my my tap follower to make this a little bit easier to get these in. Don't have like a great way to get those perfectly straight, but I think I'm just going to have to hope that it lines up okay. Okay, so let's get the tap follower. I don't know if I have enough space, actually. We're going to find out if I've got the vertical space for the tap follower. Let's crank the Z height back up here. Get as much space as we can. Okay. And where is that guy? There we go. Yeah, this is not going to be anything like, we're not going to have anything like enough space. Okay, well, that'll have to be tapped by hand as well. All right, off camera I went over and tapped those devices on the other side of the shop. I don't want to rearrange all the cameras, but pretty boring anyway. Just a couple of tapped holes. They're actually, it's nice soft aluminum. I think you can see that. Yeah, you can see that hopefully. It's nice soft aluminum. I was able to just put the tap into my cordless drill driver and just run it in. That works pretty well. Always a little tricky with the smaller taps. Don't want to risk breaking one off, but it seemed to work just fine here. And now we should be able to put the shaft together like this and use the set screw to get a good grip on that, and then on the motor shaft as well. So that should be a lot better there, and I'll put a little Loctite on those when I assemble it too, to make sure that it stays put. So then the next thing is getting a good grip on the hex nut. So let me go ahead and take that off of the lathe and get it chucked up and put a hole in that we can then use as a drill guide to drill into the screw at the end of the lead screw. That sounds kind of terrible, and it kind of is, but it seems like that's what's called for. Okay, there's the end cap for that guy, and what we want to do is drill and tap a hole in here that will allow me to put a set screw in, and again, it'll run. I want to run it into the threads on the end of the lathe, which I guess is really not awesome, but I think that might be our best choice here. So again, don't really have a great way to hold this in a way that shows it on the mill, so I'm gonna have to use it do it on the drill press, so I'll just do that off camera. Well, let that be a lesson to me. Bent that tap up pretty good. Drill driver, not as good an idea when you're working in steel rather than aluminum. All right, well, that's done. Nothing too exciting, just tapped a couple holes, drilled and tapped a couple of holes. You can see, I think that did a decent job. You grab the deburring tool there and give that a quick, I don't have one of those fancy Noga ones like Blondie Hacks and James have. Maybe I'll pick one of those up at some point. That one works fine though. All right, so that's a little better. Yeah, there we go. So, all right, so now I think I have everything I need. The next thing to do is going to be to take this guy and put it back on the end of the lathe and use that to drill a hole for the set screw to go into. Probably the scariest part of the whole operation. Also may have munged the threads up inside this thing a little bit, so that I'm not entirely sure it's going to go back on, but we'll see. Let's move back over to the lathe. All right, we're back over at the lathe, and I'm going to take and put the nut back on the end of here and hope that it didn't chew the threads up so bad that I can't get it on. It's not too bad. Throw the lock on the carriage. Just thread that on there. Hopefully the threads themselves will kind of cut it in a bit. Looks like it's working okay. Yeah, not too bad if I can turn it by hand. Okay. Actually, just to the point now where it's turning the lead screw and the carriage itself is advancing because that's what it's designed to do. So let's run it down to the end here, and hopefully that'll give it a little resistance. Throw the lock. Allow me to keep threading this on. Nothing bad is happening, is it? Oh, there we go. Okay, great, yeah. Oh, I think I'm even going to get lucky, and that hole is going to wind up lining up where it's going to be easy for me to access with my drill. Great, let me get the drill and the drill bit. Okay, well, here's hoping my drill holds this little teeny bit. Yeah. All right, and just to sort of maximize our chances for success here, let's get some cutting oil on there. And this is just scary, but I don't know if that's doing any good at all. Or do I have a way to clean that out? And if I back it off, it might not line up again. Plus it looks like that whole thing is not really... Clean that up. Pretty greasy. Yeah, that does not look like it made much of an impression at all. Well, I'm hesitant to do too much more of that. Tighten this set screw down. Trying to think what I want to do here. Got a kit with a nice assortment of these from Amazon. They've been pretty handy. Missing the right wrench. Okay. Drop one. Okay. Third time's the charm. Except you have the wrong wrench. Okay. 1.5 millimeters. All right. Now I'm beginning to wonder if, when I took it out and looked at it to say, oh, I think M3 is the right size, I think the one I was looking at was actually M4. Can't tell if that's... Sorry for my big fat head in the way, I just can't see what I'm doing. It seems to have bottomed out, but unfortunately the wrench is kind of spinning. I think I'm going to try a different wrench because that's a cheap Harbor Freight pair, which is fine, but maybe not the highest quality tool I own. Here we go. Okay, so my millimeter. This is a nice little set I have. I can see that. Kind of like this. They seem like they're pretty good. Get that in there and see if it does any better at turning this guy. Oh yeah, way better. Yeah, it's not spinning in the socket like these cheapo Harbor Freight ones. Okay, something just slipped. I don't think I stripped the set screw. It is slipping because it's such a small... Well, I think we're going to go with that for right now and see if it is enough to keep the screw from backing off. So now that we've got everything hooked up, or rather, we've got all our connections sorted out, it's going to be a matter of putting this on here, getting a set screw on there, then this piece goes there, then we grip the end of the... Which, is it catching? It might be catching on that set screw I just put on, but I think we have enough meat anyway. Oh, it's bottoming, that's fine. So we do this, and then I'm going to make a little platform for this to sit on to get it to the right height, connect everything together, and we should see it turn. But first I'm going to go eat lunch, so we'll pick this up again later. maybe another day. So if you see me in different clothes, that's what happened. All right, I'm back from lunch and thought I would take care of a quick task, which is I need to make a little platform for the motor to sit on so that it'll line up with the right thickness, so it'll line up with the motor shaft or the lead screw shaft. So I'm just going to cross cut a piece of wood for that, and then I'll plane it down to size. And when I cross cut, I actually prefer, certainly for small pieces, not to use a chop saw. I have one. I don't really have space for it in here, even if I did. But I actually find a handsaw to be very quick for cross cutting. So that's what I'm going to do. I've gone ahead and marked a line on this board, and I'm just going to cut it to length. This is my saw bench. It's made to be explicitly my knee height, which allows me to put my knee on it and hold the work down that way. And then it's pretty quick, and I sort of enjoy it. I think it's nice not to have to put on hearing protection or whatever, but you know, your mileage may vary. Alright, so obviously that's pretty quick, and it goes, get a nice saw. I'll put a link to this saw. I'm pretty sure I bought this on Amazon. I'll put a link to it in the video description down below if you're interested. I like it a lot. It was cheap. I think it was like $30. I can't remember exactly, but does a good job. It does take a little bit of practice to get good enough with it to be able to go quickly and accurately. You can see this is rough cut on both ends. I think I must have cross-cut it by hand, but if I took this over to my shooting board, I'd be able to make this nice and square and no problem. I don't know if you can see the pencil line there. Just left it. I've gotten, just takes a little bit of practice and you can get really close to sawing on your line. So pretty happy with that. So this will be what the motor sits on to line up with the shaft, and this is already close to the right length, but I'll need to fine-tune that. But let's go back over to the lathe and put the motor up on this, see if we're close, and get this thing hooked up. Alright, we're back over here at the lathe, and just took that block of wood, and I can see that I'm going to have to take quite a bit off in order to get this to line up. Okay, so it's not working. On top of that, I found out that I dropped a bunch of the audio in one of the clips, and also a whole bunch of the video from the shoot went missing. So, not my best day in the shop, but these things happen. Let's go over and I'll show you where I got to. Alright, well the long and short of it was, at the end of the day, I hadn't gotten it working. It was working in the sense that if you turn the rotary encoder, which is the sensor for the position of the headstock, that the motor would rotate, but it was losing steps. I could see that when it's hooked up to the lathe, it will not turn all the way it's supposed to. What do I mean by that? Let me actually go ahead and show you. So first of all, I'm going to turn a power on here, and you can see that the thing will come on. You can see the little version number 14 shows up. That's great. And I've got the rotary encoder here in a drill just to allow me to turn it quickly. And if we look here at the motor shaft, you can see that when I turn the rotary encoder, that the motor shaft is rotating, and that's great. And as a check, if we change to feed mode and change to 12 threads per inch, because the lead screw in the lathe is also 12 threads per inch, that should mean that one rotation of the rotary encoder is one rotation of the motor shaft. And if we look, it looks about right, but we can actually tell. I put a piece of reflective tape here on the shaft of the drill because I was using a tachometer to take RPM readings. And we can say that, well, if this is lined up with this, we know where the rotation is. So if we come around once, that should be one rotation here as well. And what I've done is I've put a little dot right down here. You can see it's next to this slit. And let me just go ahead and turn the power off on this thing and point that straight up, and then turn it back on So now when this slit is straight up, is vertical, these two are aligned, what we should see is if we go around one time, we get one rotation. And in fact, we can even run the drill fast. And after many rotations, when these are lined up, this is vertical. So it looks like we're pretty much right. The thing is, when it was hooked up to the lathe, it wasn't doing that. I could hear it kind of slipping. I think it's missing steps. I'm not sure why. I'm also not sure why it's not missing steps here on the bench. Probably noise. Everything's pretty tight in the enclosure. There's a lot. The power supply is right next to the electronics. I tried to keep things as separate as I could, but there's a good chance that there's some noise being transmitted on a line somewhere. So I will have to dig into that, but that'll be the next update. I did pick up an oscilloscope, so I'm going to have to spend a little time getting used to using that, but that should be a really helpful tool to try to figure out if there's line noise going on. Again, not my best day in the shop, but that's how it goes, you know. You get smarter while you make stuff, and the way you do that is make mistakes. Sorry about the production problems with the video. Still learning all this stuff, but if you have found this at all useful or maybe even entertaining, perhaps you can go ahead and give me a like and consider subscribing. It does let me know what people are interested in. That it maybe helps me determine what kinds of videos I should make more of. But if not, that's fine too. I just enjoy you sticking around this long. I know this video was a little bit longer, but hey, I'm having fun learning how to do this, so thanks for coming along for the ride. This is Get Smarter and Make Stuff. Thanks for watching.